Assalamualaikum students. I hope you will be good. This is another video for differentiation, which has been included in IGCSE mathematics course syllabus. Okay, so I have done some questions in last videos, my previous videos. Now this is the fourth lesson, fourth video for this topic, differentiation, and I'm doing another question now. Question number 14 I'm doing. Question 14 is here. That's question 14. Now in question 14 they say for the curve y is equal to 11 plus 6x minus x square. Now this is not in order. I'm always saying to my students, if there is a equation like this, please make that equation in order. So x square minus x square plus 6x and plus 11 is in order. Now they say find out dy dx. So we first find dy dx, which is minus 2x plus 6. Now then they say thus find the maximum value of y. Okay, so we know that this is quadratic because it's x square minus x square plus 6 plus 11. Now when it's quadratic, then of course the graph of this thing, if we get the graph of this thing, it will be either this way or this way. Now in this case, this is the case when a is greater than 0. We know that thing. This is the case when a is less than 0, and standard form for this is ax square plus bx plus c. So the coefficient of x square is a here. If it's positive, then parabola is opening up. If it's negative, then parabola is opening down. Now this point is, if it's opening up, then this is minimum point. If it's opening down, then it's maximum point. Maximum here and minimum there. Now they say find the maximum point. Now I have told you in previous videos, for maximum, minimum, stationary stationary point are sometimes called turning point. If they are asking about these things, then always put dy dx is equal to 0. Solve this thing. So already I have dy dx. When dy dx is equal to 0, it means minus 2x plus 6 is equal to 0. So minus 2x plus 6 equal to 0 means minus 2x is equal to minus 6. So x is equal to 3. Now if x is equal to 3, now since parabola is opening down, see, that's a sketch. Parabola is opening down. I'm doing it on the other side. See, in this case the graph is opening down because a is negative. It's minus x square plus 6x plus 11. See, a is minus 1, which is less than 0. So parabola is opening down. So then this will be the maximum value. Now to get the maximum value, just put the value of x, which is here, in this function, which is minus x square plus 6x plus 11. So result becomes minus 3 whole square and plus 6 into 3. 6 into 3 and plus 11. So minus 9 plus 18 and plus 11. So 9 plus 11 is what? 20. So maximum value of y is 20. And if I ask you um, how can you call it maximum value? Okay, why we call this maximum value? So the answer for this thing is, see, since the parabola or the graph, we can just say the graph is opening up, so the maximum value, the highest value of y is there. Let's see, it's 3 and 20. The highest value of the y, see, the highest, that's the peak point of the graph, and the peak point x value is this one, that's x value, and that's y value. So the maximum value of x is 3, and the maximum value of, sorry, the maximum value of the since this is the peak point, and the peak point, the value of y is always maximum value on the peak point. Value of y is always maximum. That's the answer for this thing. Okay, so I hope this question is clear to all. Now I'll just revising it again. See, very simple thing. They have given us, they have told us that there is a function. The function is this one, and they say find dy dx, which is the differential. So differential derivative of this thing is, we got here, differentiating this, we got minus 2x plus 6. Now they say find the maximum value. In this next part they are asking about the maximum value. So for the maximum value of y, always dy dx should be 0. So when dy dx is 0, we got the x value 3. When the x value is 3, just substitute this value in the function. So you got the value of x, and you inputting that in the function. So you're getting the value of y 20. That 20 is the maximum. That's the maximum value. I hope it's clear to all. Now next question. I'm erasing this question now. So now let's go to next question. Next question is, I think, 15. Let me use eraser to erase this working. Yes. Now question number, next one I'm doing after this. Okay, even I will erase this question. This is done. Okay, now the next thing is, the next question is question 15. Question 15 I'm doing now. See this question. Question 15, y is, see, y is given to us. This is y. This is y. Now if y is x power n, what is the derivative? Derivative is dy and n x power n minus 1. If y is equal to 5x power 4, what we will do? Dy dx is 20x power 3. If y is equal to x power, or just say x, then dy dx will be 1. If y is equal to 5x, then dy dx will be 5. And if y is equal to 9, then dy dx will be 0. This is just revising this concept, because I taught and I explained these rules in the previous lessons, previous videos. Now in this question they say work out dy dx. So a simple thing, finding dy dx. So see here, How to find dy dx? Dy dx becomes, look, I'm doing here, dy dx becomes, it's 2x minus 10 plus 0. It means dy dx is 2x minus 10. Done. This part done. Now see, look, they're saying here, they're not saying maximum value, they're saying minimum value of y. Why they are saying minimum value of y? Because the parabola or the graph is opening up. So that's the graph. The graph is opening up, so we say this point is the minimum point, of the graph. So here is x and y, so this y will be called minimum value of y. Now how to get the minimum value of y? See, I told in the previous question, whenever they say minimum, maximum, turning point, stationary point, just take dy dx and make it equal to 0. So 2x minus 10 becomes 0, so 2x becomes 10, x becomes 5, x is equal to 5. So put x5 in the, to get the value of y. Y is x square minus 10x plus 10. Y is x square minus 10x plus 10. So y is equal to 5 square minus 10 into 5 plus 10. 25 minus 50 plus 10. So 25 minus 25 plus 10, the result is minus 15. That's the minimum value of, so minimum value of y, this answer is what? Minus 15. Now question number next. This question is question 16. Now I hope the question 15 is clear to all students. So I want to erase that question, and I'm doing question number 16 now. So let me erase this question. Okay. Now question 16 is, first part, y is equal to 4 plus x and 2 minus x. They say find dy dx, and then they say then find maximum value of y. So I don't need this thing here, I'm going to erase this thing. Now first of all, open this thing, open the brackets. Look here, y is equal to 4 plus x and 2 minus x. So 4 into 2 is 8, 4 into minus x is minus 4x, 2 into x is 2x, and x into x is minus x square. So 8 minus 2x minus x square is equal to y. Now that's done. Now then they say find dy dx. So dy dx becomes 0, minus 2, and minus 2x. This way, or if you arrange it, you get minus x square minus 2x and plus 8. So dy dx is minus 2x minus 2. Yes. Now who will tell me that parabola, the graph is opening up or opening down? See, who will tell me about this thing? The graph is opening up or opening down? Look at this thing. Look at this thing. Look at the coefficient of x square, which is negative, minus 1. c minus 1 is less than 0, it means graph is opening down. That's why we say maximum value here. So to get maximum value, I have already told you, put dy dx equal to 0. So minus 2x minus 2 equal to 0, minus 2x is equal to 2, and x is equal to what? Minus 1. When x is minus 1, how to find a maximum value? Maximum value y is equal to 4 minus 1, replacing x with minus 1 and 2 minus minus 1. So we get 3. We get 3 here. The result is what? 9. That's the result for maximum value of y. That's the question. Now, question 16 also done. I hope it's clear to all. Let's do some more questions. I will need to erase this question now. Now, the next question I'm doing is I'm doing question number now. There's another exercise. I'm going to that exercise now, and I'm going to solve a question from that exercise. Question number 1. Question 1 is, for the curve, there's a curve y is equal to 3x square minus 7x plus 5. First part is what? First part is find dy dx. They say find dy dx. So how to find dy dx? Look, for dy dx, we get here 6x minus 7. That's the differential. That's the derivative. The second part is, the second part they say just find the equation of the tangent. Find the equation of the tangent at 2 and 3. So now see here, to get tangent equation, tangent basically a line. Okay, this is a line. Like for example, I say this is a curve. There's a point 2, 3 here, and there's a line. This line is passing through this point. So this point is called tangent point. Now what is the equation of this line? Equation of this line is always y is equal to mx plus c. How to find m? For finding m, see, put x here 2. So 6 into 2 minus 7 is 12 minus 7, result is 5. Now y is equal to 5x plus c. Now how to find c here? To find c, we input the value of y over here, 3 and 5 into 2 plus c. So 3 is equal to 10 plus c. 3 minus 10 is equal to c, and c is equal to minus 7. So then that's c value. Equation becomes, this becomes what is the value of m? 5, x and minus 7. That is the equation of the tangent. I can write also here in this way, a is y is equal to 5x minus 7. That's the result. Okay, this question done. Let's do one more question. Now, question number 2 I'm doing here. Question 2 says, question 2, they have given curve equation is given to us as x square plus 4x and plus 3. So find the values of x for which y is 0. Okay, they say find the values of x for which y is, find the values of x for which y is 0. Now you all know that if this is a xy plane, okay, this was 1, this is 2, this is 3, this is 4, minus 1, minus 2, minus 3, and so on, 1, 2, 3, 4. So look at this point. This point is 2 and 0. This point is 4 and 0. So on the x-axis the value of y is always 0. So when they say find the values of x for which y is 0, it means the point is on the x-axis. So to find those values of x, just input y is 0 in this equation. So when y is 0, x square plus 4x plus 3. Now if x square plus 4x plus 3 is equal to 0, you can use quadratic formula in the calculator. I'm using here factorization method. So I get 3x square. Now I will search two things whose product is 3x square, and when I add them I will get 4x. So 3x and x, if I multiply these two things I get 3x square. When I add them I get 4x. So x square plus 3x plus x plus 3 is equal to 0. X is common here, x plus 3, 1 is common here, x plus 3 equal to 0. So x plus 3 and x plus 1 I got equal to 0. So x is equal to minus 3 and x is equal to minus 1. So these are the points. See, one is minus 3, one is minus 1. One point is here, one point is here, one point is here. Now look at the graph. The graph is opening up. It means our graph is opening this way. It's just a rough sketch. It's not the original graph, just a rough sketch. This point is what? Minus 3, 0. And that point is what? This point is minus 1 and 0. Now we got these 2 points. Now they say in next question, this was part A. This was part A. In part B, they say find dy dx 0. So find dy dx part B. Dy dx 0. Sorry, now just find dy dx, not 0. Just find dy dx. Dy dx is part B. Now what is the equation with us? Y is x square plus 4x plus 3. So dy dx becomes 2x plus 4. That's the derivative. Now how to find part C? In part C they say find the gradient of the tangent at the point where the curve cuts the x-axis. Okay, fine. I'm writing this part here. In part C they say find the gradient gradients of the tangents at the point where the curve cuts the x-axis. Now we have seen that thing. that the curve is cut in the x-axis, where the curve, yes, where the curve is cut in the x-axis at this point and at this point. So we have to find gradients here. So how to find gradients here? It's very simple. Now the points, the gradient function is this. This is basically gradient. This is your m. Gradient is already, we got gradient as dy dx. Now if we put here x is equal to -1, we get dy dx, which is your m, is 2 into -1 plus 4. The result becomes what? -2 plus 4. The result becomes 2. That's the first gradient at the point -1. Now how to find the second gradient? For second gradient, just input the value of x -3. Now see here, x is -3, so dy dx is 2 into -3 and plus 4 becomes -6 plus 4. It becomes what? -2. So we got the values of gradients at these 2 points. Now I'm going to erase some parts here. I'm going to erase this part. Now they say find the equation of tangents. Equation of tangents at these points. Now see, I'm making a rough tangent line here. Look at this line. At this point, tangent line is this one, and at this point, tangent line is this one. See here, these 2 tangent lines are there, and we got the gradient of this one. Gradient for this one was 2, and gradient for this one was -2. So we got here m1 -2 and m2 we got here 2. We just did the working there, if you remember them. One was -2, one was 2, and the second one is -2. Now they are talking about, now in this part, next part, they say in part B, write down the equation of tangents. Yes, at these points, at the point where the curve touches the x-axis, find the equation of tangents. So how to find equation of these tangents? Equations of these tangents. Now first I'm doing for this one, for this line. This is what? Y is equal to m2 x plus c. So what is m2 here? m2 is 2x plus c. Now how to get the value of this c? See, this is the point where when the curve cuts the when the curve is cutting the x-axis. So this point is -1, 0. So input the values here. The value of y is 0 and the value of x is -1 plus c. So c becomes what? C becomes 2. Equation becomes y is equal to 2x plus 2. That is equation for this tangent. Now how to get the equation for the other tangent? I'm doing it there. I'm going to erase this part. Now equation of the other tangent line, which is this one, I'm doing for m, the gradient of the tangent is m1. So I'm writing here y is equal to m1 x plus c. What is the value of m1? M1 is sorry, it's not m1, y1, just y. Now y is equal to minus 2x plus c. Now what is this point? Point is minus 3, 0. So 0 is minus 2 and minus 3 plus c. So 0 is equal to 6 plus c. C is equal to minus 6. So y is equal to minus 2x minus 6. That's the result for the second tangent line. Okay, so I hope this is clear to you, and you please do these questions yourself. After watching these videos, solve these questions yourself. Inshallah, you will understand them. Inshallah, next video I'll be doing more questions, and we will be doing how to find the equation of tangent, and how to get the gradients of lines, inshallah, in next questions. These questions, inshallah, will be helping you to understand the concept, and inshallah will be helping you if there's a question coming exam paper. Inshallah, you will be able to solve those questions. Okay, Allah Hafiz.